Welcome back to my channel again. This is the second part of the tutorial about Sentinel-2, how to detect flooding extent. In the first part we have seen how we can download flood images of Sentinel-2 during certain days. Here I have my site of Betu. I have OpenStreetMap as a background and some information, and as well I have the perimeter of my site. I upload the images. I click on the Add Raster layer. I browse to the area where I have downloaded the images. Those are the images, and I open them. Here I have the images of Sentinel-2 based on the date 13, 18, 23, 7 and 14. You see the flooding on the 13, the flooding plus clouds on the 23, the flooding on the 7th. Fine. Now we should vectorize those raster images. But before vectorizing the raster images, I would like to spend a few words about the date of the 23 December. Here you see cloud, and when you have clouds in Sentinel-2 you have to be very carefully, because very frequently Sentinel-2 detect the shadows of the cloud as a float, as water. So therefore I would not take this area as precise. At this point we need to vectorize those images. We start with the 13th of December. First let's zoom to the full extent. We see we have three types of color. This is most probably cloud. Let's check the value of those colors. We click on the identify icon. The green is band 279. The water is band 255, and the cloud is band 228. So we know that water is 255. To vectorize this raster file, we go to raster, conversion, polygonize. We choose the right layer, 13th of December, the band 2. The DN we can keep it as it is, and we run. So we have this one. Now we need to keep only the water, which is number 255. We can open the attribute table. We click on the filter icon, and the n must be equal then 255, and we select all the features that have the n 255, so the water. And at this point we invert the selection. Now we have selected everything but the water. We click on the editing icon and we delete everything except the water. So now we have only the water. We can change the style, water. Just be careful, this is a temporary file. I will change the name to avoid misunderstanding. Rename layer, and I call it 25, 12, 13. I do the same exercise for the other raster layer. I speed up the video. Here, where I have clouds, I have to be more carefully, because as I was telling you, frequently the shadow of the cloud is detected by Sentinel-2 as a flooded area. January. Of February there is no flooding, so I deleted it. Okay, fine. Now I have this 4 layer, and I want to unify this flooding. I go on the processing toolbox and I look for the command merge vector layers. I choose the 4 layers. Now I have merged all the vector layers. still temporary layer. Doesn't look nice. Next command would be dissolve. I dissolve the items. Select this command, keep disjoint feature separate, and you run. Now I have everything together, but I want to do it smoother, and therefore I type here by the processing toolbox smooth, and I will smooth of the offset 0.4 to see what it does give. This is 0.4, and let's smooth with 0.5, and let's see what looks better. You cannot go more than 0.5. This is 0. It looks very. This 0.5 looks better. So I can remove all those temporary layers. I will style the smoothed layers and make them permanent. First, I take away the solid line. I choose a blue color and I make it kind of transparent. Okay, fine. And I do it permanent. I call it Sentinel-2. Okay, I changed the name as well here, Sentinel-2. It would be interesting to compare the result between Sentinel-1 and Sentinel-2. I take the Sentinel-1 layer from the previous tutorial. This is this one. Okay, now we have the two floats. We style it again. So we can see that the Sentinel-1 identified much more flooded area. This depends a lot as well on the JavaScript, on the algorithm that you develop with the ChatGPT, and Sentinel-2 detected less water. So what we could do at this point, we could also merge the two Sentinel and we would have the final float. Merge. We choose Sentinel-2 together with the float of Sentinel-1. Here it is, same process. Now we dissolve those, okay, and we make it nice looking as well. Now line and transparent. At this point we have our flooding map based on Sentinel-1 and Sentinel-2 together in the day of December. You see, big part of the city was flooded. This map needs to be verified as well in the field. You may play around with the sensitivity of JavaScript through the ChatGPT and to fine-tune the detection of water. We can compare as well the flooded area with high-resolution images to see if there is a correspondence between our detected flooding and the soil. This is the high-resolution images of the area. For example, here you can see kind of less vegetation, and when we choose, we see that there is kind of correspondence. Let's see somewhere else. So at this point you need to confront the flooding detected to the satellite together with the analysis of depression, together with watershed analysis, and try to check if the flood analysis that you have done so far looks realistic. Thank you very much for following to the end.